There we go. All right. Let's see. We got a couple of things today. We've got, on Canvas, quiz 1 will open this week and it'll stay open for a week, so you can work on that. You don't need to do it right now, but it'll stay open the whole week until next week. And it takes, 30 minutes total. Maybe it doesn't even take that long, depending on how well you know the thing. It's all multiple choice, so it should be pretty straightforward, and it shouldn't take that long to do. But I think if you set aside 30 minutes, you'll certainly be able to do it. Let's see. Last time we were working with some TPU. We had this roll of TPU out. We also had a couple of what else were we doing? We did. Let me look back at the notes here. Oh yes, we talked a little bit about a all metal hot end, and I was showing you one that I thought was not all metal, but it turned out it was. But now I've got two. I've got two here. So let's go down here so we can see. All right. So just as a reminder, we're talking about. I got them in this little case. This piece. So here's two different versions. The outside is not really the important part. They are different on the outside for this one. But these are the heat breaks that go between the heat block and the heat sink. And they mechanically connect them together so that they're, connected. And the filament will go through this heat break. And it's the part, since it partly connects to the heat block, it's going to be hot on this end. And then the other end, one way or another, this one connects with a set screw. This one actually screws in. Let me get closer to them. There we go. Get them more. Where's the middle? There. All right. So the what was I saying? Oh yeah, this one just kind of attaches to the heat sink with a set screw. This one actually screws in. That's not the important part. That's just a different way of connecting them. I guess you could sort of argue that the set screw has less physical contact, so there's less conduction to the heat sink up here. Here's a piece of it kind of off the screen. And so maybe that's a little bit better. A little less mechanically stable, but there's not really any kind of side load or anything on these to worry about. So maybe this is a slightly better idea. Also, this one, so this one is the all metal one. And it does have a smaller throat. You can kind of see right there. The throat that's connecting them is very small compared to this one. Not that this one's large, but it's much different there. So what they're trying to do is get a thinner wall so that there's less material for heat conduction, because they want to keep the heat from here out of this area. And I had showed you, here's a little piece of Bowden tube that on this one, this is one we had last week, when you push the Bowden tube in, it only goes about that far. So I don't know if you can tell, but there's where it's at. Only, 5 millimeters. And I don't know if we'll be able to see inside these or not. Yeah, you can actually see. Let me see if I can get it in a position you can see pretty well. So see how it narrows down in there compared to this one. This one is not all metal. Now, this thing is all metal. That thing is all metal. Both of them are all metal. The difference is on this one, when you install this, the Bowden tube will actually, in this case, go all the way through. Like, it actually comes out the other end. So that puts this tube sitting right on top of your nozzle. Right there. So they sit right on top of one another. And so this end of the tube has, to whatever temperature you're printing at, it has that temperature sitting right on the end of it. And that's the problem. Well, if you're printing really high temperature stuff. So if you're printing 240 or higher materials, then the not all metal one, this kind, well, we're off the screen. This kind, see if we can move them closer to the middle. They're very not well. Maybe turn them over this way to stand up easier. Oh, you can actually see the output holes a lot easier that way too. So the not all metal puts the Teflon tube, which degrades beginning around 240 degrees Celsius, right on the nozzle. It's like touching, it's flush with the nozzle. So if you try to print 250 or 260 or 300 or whatever, this kind will have the Teflon tube exposed directly to that high temperature, and it will degrade and eventually fail. This kind is the Teflon tube is nowhere near the extreme heat of the nozzle. It's it's not that far. It's an inch away, less than an inch away, but it's pretty close. It's not sitting on top of it, so it's pretty far away, and it's in the region where the heat sink is, which is cooling everything down, and so you should be able to print 300 degrees or whatever. There are other things that happen. So at around 300-ish degrees, if you're really trying to print some really hot materials, which your open air printers like this Ender 3 that we're looking at here probably is going to really struggle with some of those really high temperature filaments. They do exist, and they kind of have different printers that run them, and they are much stronger in general. They have better properties in general than the actual filament. But once you get around 300-ish, you get a new problem that we haven't really talked about too much, but this little hole is for the thermistor, and the types of thermistors we have. I actually had one out the other day. I don't know where I put it. I probably can't hand it. It's a little glass bulb, right? Is what it is, but it's measuring the temperature. And they start becoming non-linear around 300 degrees Celsius, the kind we're using. So you have to switch to a different thermistor to measure those higher temperatures. So you run into one problem after another when you try to print hotter and hotter materials. But if you're just trying to do like ABS or nylon is the one I'm thinking about, that probably ABS and nylon, maybe ASA. Those start getting into the regions where this kind, not all metal, will fail over time. The 250 temperatures and stuff like that. And you want the not all metal, even though both of these things are all completely metal. In fact, some of these kind are multiple metals. They might have this little throat here might be made of titanium for its strength, and then the other parts might be made of a more heat conductive, thermally conductive material, so that they can get the heat to where it needs to be and not get it where it doesn't need to be. So some of these are bimetal is what I don't think I have any to show you that, but some of these are actually multiple metals attached to one another. So if you start printing regularly above 240 Celsius, you do need to find you an all metal hot end. And you can't just look on the outside. You could have one, well, I guess you could look at this one and say that, well, this one has to be all metal, because there's no way that this tube is going to go through that little throat. The tube is bigger than that throat, so it has to end at least there. But it actually ends up there where it's not threaded. All right, so I did find one of each kind, so you can kind of see the difference in all metal and not all metal. All right, we did the TPU stuff. What else did we do? We did HueForge a little bit. I played around with it some to sort of show that you can take a PNG, or like a regular picture that you cut out of the internet. Either you copy it, or you download it, or you create it yourself, and you can use the HueForge piece of software to, depending on what material filaments you have, color filaments, I guess the material doesn't matter as much as the color of the filament, you can create a colorized version. It may not match exactly, depending on what kind of colors and how many color changes you want to make, but it will give you a representation of the picture that you have put into the HueForge. It wasn't free. UForge costs $24, but it's a permanent license. You pay for it once and you have it forever. So there's no subscription or anything. And I showed you one that I had done of a piece of the Great Wave. And it actually came out pretty well. All right, so today what I thought we'd do is a couple of things here. So one, on the printer, I've got a different print bed. Oh, we're zoomed in. I've got a different print bed on here right now. So these are, there's several of them. I have one, looks like, this pattern. One that looks like a carbon fiber weave. I think those are the only two I have handy. In fact, this one is actually just the other side of the bed we've been printing on. So it's dual-sided print bed. Some of them are like that. These are a different material. So this gold, this is PEI, and it's a really good material for printing most of our materials on. What it does is when it heats up, it actually bonds to the print material, the filament, and really holds on to it pretty well until it cools back down, and then it releases really easily. I believe this material is PEO. I think that's what it is. And it doesn't necessarily do that same thing. It does hold okay. It doesn't have nearly the same holding power as the PEI. Its reason is that you print on top of it, and this pattern is made up of, I guess, micro etches. So it's actually carved into this bed, and so when you print on it, that pattern gets embossed in your print, whichever surface was on the print bed, obviously. But you can kind of see, you'll have that side at least. First of all, it's shiny because this is relatively shiny, and then that pattern gets built into your print. It doesn't work. I tried it on TPU. Doesn't work as well on TPU. You might, on the camera, you're not going to pick it up at all. In person, you can tell. Actually, I don't even know which side. I think this was the side. Yeah, you can't see. It is there very slightly. I thought it would actually show up pretty well on TPU, but it didn't. This is a piece of PETG, which did not stick too well. I had to really embed it in the surface pretty far, so like move the nozzle down so it was really squishing down. In fact, I think I was probably printing a little bit hot, and you can kind of see. Can you see? Yeah, maybe in the reflections you can see it's warped a little bit. It's not perfectly flat on the bottom. It's close, but it's, I don't know. You can't really see that it's bowed a little bit, but it is slightly. Yeah, actually, right there you can see that it's a little bit bowed. But the main point of this kind of bed is that it will put this pattern into your print. And so they come in different, like I said, a more randomy one, a weave type one. Let's see if I can find, there's some that are all sorts of different patterns. If you go to Amazon, I think if you look for PEO build plate, let's see if I can. No. Yeah, there's some. All right. Where are we at? That. All right. Here's a pack of them. Now this is a larger sheet here, so you do have to make sure this is 235. Oh, 235 by 235. That would fit on the Ender 3. So you do have to make sure they would fit, size-wise. Most of them are magnetic, meaning that you also need a magnetic bed, or you clip them down with the little binder clips, whichever. They're made usually to be on a magnetic bed. There's one that's basically the one that I have. Actually, I don't know if it's the one, but it's very similar. Most of these, this black piece in the back, that's a kit so that if you don't already have a magnetic bed, this is the magnet. So let's go back over here. So underneath here this is just a giant magnet, kind of like the refrigerator magnets. And you take off whatever bed was on there before. Usually it's just one of the flat sheets. Let me see, I do have one. We can look at a whole assortment of beds. So usually you just have this guy sitting on there, right? And it might be clamped on with some of these kind of binder clips. So you take that off, clean it up because it's just an aluminum sheet underneath there. Clean it up with some isopropyl alcohol, stick this down, and now you can switch out all sorts of beds, and you don't really have to use the binder clips to hold this down. It's enough, you know, it's not a super strong magnet, but it's enough usually to hold these beds down. And so then you can put this bed on. You can still use this kind. You just do have to hold it down with a binder clip. You can use a glass sheet. You know, maybe you want. Let's see, is this stuck to something? Oh yeah, that's a. So you can use a glass bed. Now, if you, let's say that you're printing on this, take it off. You put, the glass is not magnetic, obviously, so you have to clamp it down with your binder. Actually, these might be too small for that particular one, but you clamp it down with your binder clips, print on it for a while. The one thing you have to be careful of is that if you don't have a bed sensor, so you don't have this guy, then these are all slightly, well actually this is quite a bit thicker, so you know that's 3 or 4 millimeters thick, where these sheets are not even really, maybe they're 1 millimeter thick, you know, something like that. And so if you don't have some kind of bed sensor, it's got some goop on it, then you will need to adjust your Z height every time you switch. If you have a bed sensor, then you can put any thickness on here that you want, and it's totally fine. It will detect the height. So if you do plan on switching beds periodically, you know, often, then I would recommend having a printer with a bed sensor. Let's see, do you recommend rewatching your lectures for the quiz? No, I wouldn't rewatch the lectures for the quiz. I think the quiz, it's not open book because there is no book, but it's open. So it is timed, but I think the time is plenty long enough for you to not have to worry about the quiz being difficult. There are all sorts of materials that you can print on. Let's see, I was looking through my stack here. A lot of my stack is these things because I usually don't print on these. They're fine and they actually work pretty well, but I usually like the PEI sheets, so I'm usually on one of those first. I've even got over here this, so this one's covered with glue stick, but if you want shiny, you know, without the pattern obviously, but shiny surfaces, just get a plain sheet of glass. This is a picture frame glass that I cut down just using a regular glass cutter, and you can cut it to the right size, clamp it on with your binder clips. If you put the glue stick on there, you're not going to get shiny. It's going to be you know, kind of rough from the glue. But if you just print straight on it, clean glass, it works really well, and you'll have a glass-like surface on the bottom of your print, whatever surface you put on here. I don't remember what I was printing on here that had so much glue stick on it, but this is just a regular sheet of glass. Here's a smooth PEI sheet. So this one's actually a Prusa sheet. So these are the ones, so this is the same PEI material that you would print with what I've been using, the gold one that's kind of rough. The difference here, obviously this is smooth. The main difference is that some materials will stick too well to the smooth ones. So TPU in particular is bad about that. And this is a film that's applied to whatever the base material is in this case. I think it's spring steel. And some of those materials that stick too well will stick to this and they will rip this film off of here. So you do have to be careful. Does the material stick well to the glass when printing on it? Yes, if it's clean. So you do have to clean the glass, hot soapy water first, and then I usually have, like, this is my little spray bottle of isopropyl alcohol, and I spray it down before I print, and then I wipe it off with a microfiber tool rag, and it prints it really well. Except TPU sticks to glass too well. So if you don't put something like hairspray or glue stick. That might be what I was doing here. No, this looks like a PETG that's stuck onto it. Oh, well, PETG sometimes can stick too well to glass. So there are some materials you need to search, you know, printing whatever your material on glass and see if you need a release agent. So there are some that actually stick too well to glass. But PLA, regular PLA, no, it's fine. How many questions in the quiz? You know, I'll check real quick because I don't know, and that'll let me tell you how long it's open for. Let me look at the quiz for 1 second here. It is, maybe there's no time limit. It's not open yet. I haven't opened it yet. Where is, oh, that's in the, hold up. I might have to look at the quiz because it's, there it is. No? That's an assignment. It's not an assignment. What happened to it? I think it's around 30 questions in the quiz. I've got to find the quiz. You know, it was built in Moodle and now it's in Canvas, and it's being kind of weird on what's going on with it. I'm not sure why it's showing up this way. I'll have to look at it and see what's going on. But there's about 30 questions. And it's not open quite yet. Let's see. That was all the questions. So, oh, well, here's one other sheet. Let's see. This one's like straight metal. Like you can print direct on metal. I don't do that very often. I don't know a real benefit other than it's smooth and you get a kind of shiny surface finish. I think the other side of this is a smooth PEI sheet. So maybe we'll get that one out and print on it because we haven't printed on straight up metal before in this summer. So you can have all sorts of different build surfaces, some for different reasons, some for just having a backup build surface. Maybe a print gets stuck too well and you're having trouble getting it off. If you do have that, if you have a print and it sticks down to the point that you kind of can't get it off of there, one thing you can try is take the build, assuming that you can take the build surface off of the printer, take it, put it in the freezer for about 15 minutes, and that usually, not every time, but usually it will cause your print to contract, but at a different rate than the bed contracts because they're different materials, and a lot of times it will release it that way. So you can actually use the thermal contraction of the two different materials, your printed part and the print bed itself, and get it to pop off of there that way. Usually with the PEI sheets, nothing sticks, with the rough, you know, the textured ones. Nothing sticks once it's cooled down so to the point that you can't get it off of there. I also have, I think I showed earlier, I don't have it out, but I also have a little spatula tool that that I use. Oh yeah, we were looking at these, weren't we? So I was telling you about the magnet sheet. So if you don't need the magnetic sheet, then you can get one of the packs like this kind that's just the bed itself. Okay, so this one is PEO. That one's actually a PET material. Here's one with a, I don't remember if the colors actually transfer or if it's just the pattern. I actually kind of think there's the way that this one works, there is a little bit of color transfer too. I think it's more diffraction versus actual color, but I think it does actually show up as a color-ish thing. Maybe we could get one of those and try it out, because I've never printed on one of those. Why don't we, which one should we get? This one's got two different colored patterns. We'll get this one. It's a 235 by 235, and it is spring steel, meaning that it'll stick down to the magnet bed that we have on our printer. So $16. It's a two-sided, so we get two, but it's only one bed. So you flip it over. We'll try this one out, and I don't know, it should take prime. So it says we'll get it by July 2nd. I don't know if we actually will or not, but we'll try it out and see. Um, let me get that thing. I'm going to save 11%. It says. Oh, when you click on it, there's another cool one. Look at this one. Maybe we should get this one. That one looks kind of cool. I don't know which one's better. Maybe we'll get the first one we looked at. All right, let's get that and see how it works. So with tax, it ends up being $17.40. So we'll try that out. All right. Other things that you might want to try. So we did the Hue Forge deal. It's pretty cool, but it is time consuming. It takes a really long time to slice, a very long time to print, and you have to do filament changes. But the results are really cool. There's another process that is using the print, but it's instead of a frontlit type thing like the one we did with Hue Forge, where you just look at it and it's the different colors are used. It's a transmitted light approach where what you're printing is different thickness layers, and the whole point is that if you put a light behind your print and let it shine through the print, the thicker layers will let less light shine through, and the thinner parts will let more light shine through. And so that's a lithophane. Okay, so John says that it's the way the light refracts because the build plate transfers that pattern onto it. So it is a refraction, diffraction kind of thing. So that sounds good. We're going to try it out. So the lithophane. So there are several. This site is called itslitho.com, itslitho.com. And this was a free site. There's also one on MakerLab, Make My Lithophane. Now this one's showing a color lithophane. That's another level to it. But the idea here is that you have an image, and here they have an image of a cat, and the software, or in this case the online tool, will create a model that you can print, and it will have various thicknesses to the model, and when you shine a light from the back of it through it, it will show the image. And it's surprising how clear the image is. You wouldn't think it. You should do one of these just to see how it works. And this one's a free version. We need an image to actually load into it, though. Let's say that we want a image of a car. So let's see. We need one with some contrast in it. Which one of these should we use? I like that one. I like the ones with the white background. Let's just use this one. So we'll take this image and whoops. Let me see if I can. We'll just copy it this way. And let's save this. So the image itself just needs to be a clear image. It doesn't have to be anything in particular, and it doesn't have to have a white background. So this is going to be this screenshot. All right. Then you go to whichever one of these. This one again, it's itslitho.com. I'll put it in. It's hard to say. Itslitho.com. That's where it's at. Put it in the chat. I think I spelled it right. And we'll get started. So, let me make this to where you can actually see all the buttons. And you can see the web page name. All right, so the first thing it's asking is, actually it's updating that there's different shapes in here. That's not what we are interested in. We'll take just the regular rectangular shape, but there are different shapes of what little frame it's going to print in. There's curved ones, there's boxes, there's spheres, there's all sorts of different shapes. This actually looks like the shape of our image, so we'll do that. Let's upload our picture. So we will find it. I assume it's in downloads. Nope. Maybe it's saved it to the desktop. No, actually we could use that. I don't see. I don't know where I actually saved it at. Oh, is that it? I think that's it. Yeah. All right. So there's our picture. Now let's go back to edit. So there's our picture in the image viewer. These channels over here are we can, if it ours was a ours was color. Ours was a color picture. Yeah, it was blue. So we could edit it to try and bring out different parts of the car or the image better or worse. Maybe make it higher contrast or whatever you want to do. You can edit that. We're not going to worry with that too much. Generally, it gives you some decent results just using whatever it generates. So now it's brought it into here. Now if we turn it sideways, this is what it's planning on printing. So see, everywhere it's dark, so like the body of the car, those are thicker, more layers stacked on. Well, now this is going to print standing vertically. You can print them flat. They'll be much faster if you print them flat, but usually you can't get the layer thicknesses thin enough to really work laying down flat. And so you usually print these standing up. But there are thicker areas where it's darker, and where it's lighter, they're thinner. And the net result is when you shine a light behind it, you get something that looks a whole lot like the actual photograph or picture that you put in the thing. You can edit all of those if you want to, change the size, change the border, put a different kind of frame on there if you don't want the frame around it. I actually would do the frame because it actually helps it print when you're standing it up. I guess you could do border. No, actually border doesn't look like it works. So let's do frame. Because it gives it a little bit more area to stick down to your print bed. You can also print with a brim to help it hold down, because it is better, unless you're able to print really thin layers, it's better to print them standing on this bottom edge, standing up like this. Here, just more options. Enable lamp puts a little thing back here where you can actually put it on like a night light or whatever. I usually don't do that, but you can. Oh, here's the night light one. So it goes around a little night light. Let's see what else is in here. Different options. So if you turn off no light, now this is what it's actually going to print. Now it does work better if the material is a light material, because if you print this in black filament, then it's not going to light up very well. You need a very strong light for it to work. So a light white or a light gray, something like that is going to work a lot better as far as giving you the image result you actually want. So that's what we're expecting it to look like. And you can change all that stuff. So where do we get our... Oh, here it is down in the bottom right corner, download. So we'll download that. We will have to look at some ads. So we're going to do the regular lithophane. There are color versions. We're not going to try and print this one in color. But there's two main ways you can do color. One is you can have a printer that has the 4 color CMYK, so cyan, magenta, yellow, and black. And you can actually print them in color. An easier and probably better way, if you have access to a color printer, is you print your lithophane and then you print like a color filter on a sheet of paper, put it behind it, and then the light that goes through the lithophane also has to go through that color piece of paper, and that will color it. I'm not sure which way they're going to do it here, but let's just download our lithophane. Alright, so it downloaded. Now we go into Cura. Oh, we'll come back to this in a minute. That's interesting. So let's find our... Actually, let's get rid of this one first. Now let's find our lithophane. These are kind of large files again because they are, it's a lot of detail in here. So here's what it looks like it's going to print. So it looks like that's not going to do anything, but it really does work surprisingly well. Like I said, you should print one. They take a long time to print. like I said, normally you print them this direction. So in this kind of printer, where the bed, oh, it's locked up right now, where the bed moves this way, a bed slinger printer, you want your lithophane organized this way. So it's standing on its end, so you get more detail in it. And it is not, it is aligned with the motion direction of your bed. Now, if your bed doesn't move, you have a Core XY printer or something where the bed just moves up and down, it doesn't really matter which orientation you use. But with the bed slingers, you don't want, let's turn it the wrong way, you don't want it to come in this way, because as the bed moves back and forth, which yeah, there we go, the bed's moving back and forth trying to print this thing, it will get wobbly at the top, and it'll print fine for half of it or whatever, but it'll start getting a little bit of noise in it at the top as your print bed moves back and forth. Now, it doesn't have to move back and forth very far to print, but something like this. So it might not be too bad, but it's better if you have it lined this way so that when you're moving back and forth, it's really just moving in the line of its own major axis. The other things, you usually want a smallest layer height that you can deal with. And deal with, I mean print, but also how long it's going to take. Let's try slicing this thing. Normally, you don't want any infill. It should be thin enough that there's very little infill, because if you have infill, that pattern might also show up in your lithophane, and now you've got a kind of checkerboardy looking lithophane. So instead of making your infill higher, I would just increase the walls. So I don't know how thick this is. I guess if we went back to here, let's see. It says it's 3 millimeters. So that means we would need, oh, well, actually the depth is 4 millimeters. So I don't know, maybe that's the little frame around it though. So if we're doing a 0.4 millimeter line width, because we have a 0.4 millimeter nozzle in our printer, then we would need, two walls would actually give us 4, 2 on each side. So 4 times 0.4. So we need like 4 walls or so. Actually, that's what we have. We have 4 walls in here. So let's slice it. They do slice a little bit slow. Not as slow as those Q-Forge type printings, but they do take a little while to slice. Oh, make sure your support is off. I didn't check that. All right, so what we want to know is we want to make sure that there's no infill in here. So we'll just scroll down. It doesn't matter if there's infill in the frame so much, but in the print. So it looks like everywhere is going to be solid walls. Yeah. Now this one doesn't say it's going to take terribly long, 2 hours and 50 minutes. That's not too bad. Now we're at a thicker layer, 0.2 millimeters. You probably want a little bit thinner one. Obviously, the thinner you go with the layers, the longer the print is going to take. But 3 hours is not horrible, and it should work pretty well even at 0.2 millimeter layer heights. So I would add a brim though. We have a skirt on here. Let's add a brim. I would actually add a brim just to help it stick down, because there's not a lot of surface area there. Slicing. So added 4 minutes, but I think this brim at the bottom is worth it on this kind of print. And like I said, if we go back to slow here, you can print them this way. It will obviously be faster. You would certainly want to go as low of a layer height as you could. Maybe, what could we do on this printer? I think it could probably go down to 0.12 probably. We don't need the brim now. We could turn the brim off. We got plenty of surface area holding it down now, all of that. So we could turn the brim off. I didn't turn it off though. We could do back to a normal amount of walls. I think I had 4 on there because I was trying to print something that was actually kind of strong. Still takes a while to slice. And it might not be much faster. Let's see. It'll be more stable as far as printing. It's actually longer because we made a thinner layer, I guess. Let's preview it. So you can kind of already see you don't have the same level of detail that you had before. It will work, but it looks like it's going to take an hour more and be less detailed. The only thing you gain is that it's definitely going to have more area to stick down to your bed. So I would actually not print it that way. I would print it the way that we plan to print it. That way. So we can't print, we won't be able to do that in class because it's longer than the class period. But I'll print one of these offline and we'll come back and look at the results of what they look like. But I would, this is one of the optional things. I would print it even if you weren't going to do an optional, just so you can see how they come out, because it's surprising. It looks like, well, that looks interesting, but not that great. But it actually is pretty impressive, the way it works. Try one of the color ones if you want to. The only thing is I wouldn't waste the time it takes if you don't have a light colored filament. If you only have dark colored filaments, then it's not gonna work that well. That thing that was on here before. So this guy is this flexi hinge wide. I got it from Thingiverse. This right here. This is called a living hinge. So you see living hinges all the time, not necessarily like this shape, but any of the little, I'm trying to see if there's any around me right now. Yeah, there's one right here. So any of the plastic stuff that, has a built-in hinge right here as part of it, it's not a separate attachment. That's a living hinge. You can actually print those. And there are some general guidelines. Thinner is actually better, and if you're able to arrange your print where they actually print the hinge part, now this one wouldn't work really well, but the hinge part actually on the bed, and you are able to print it with the line of the filament, then they'll actually work pretty well. But this is a different kind. This one actually showed up in laser cutting, so you would make these in wood. And you could have flexible wood. So I printed one of these, but it's on the printer in there. Hopefully, let's check on it. Let's see. It says it's done. Let's see if it actually looks like it's done. Yeah, I can see it down in there. So let's go get this off of the printer, and I'll come back and see how they work. Alright, so this is just PLA. Where's our printer? So PLA, it printed. I didn't print it on this printer just because I didn't have time. I printed it on the Bamboo. This particular one was 30 minutes on the Bamboo. Well, let's see if we can look at it. It was 32 minutes and 47 seconds on the Bamboo printer. On this printer, it was going to be an hour and 2 minutes or so. Mainly, it's not it's very thin, but mainly because there's so many little lines to make across here. But this is regular PLA, and if you need a part that it needs some flexibility to it, these little living hinges let you do lots of bendy stuff without really worrying about it breaking, because no individual piece here is having to bend very much. So the way these are designed, and it doesn't have to be this long. A lot of times they're like this long, and it's doing something like this, like a book or something like that, or a lid on a box or something. It does need a relatively large radius to be able to bend, but they hold their shape more or less. If you keep them closed, closed for a while, they will kind of tend to want to stay that way. They won't necessarily pop all the way back. It's already not going all the way back. And certainly if they get heated up, then and they will stay in whatever shape they're in. So these are called living hinges. So this one, you can just get, you could download a piece of this one and add it into your model with Mesh Mixer or something like that. Just build it in. They have another version that has some little pins on it that you can actually pin it to your model. There's just a longer one. And they're all over. This one's actually not called a living hinge. This model is called Flexi Hinge Thin. So I don't know if there's a Flexi Hinge thick. I guess the wide and thin is the one, and short. But there are all sorts of them. This one was actually uploaded 10 years ago. So they're just an interesting thing. So they kind of flex in the other direction like that, but not really. It's really meant for flexing this way. There's another thing you can do that is more of a technique than the geometry itself. So this one's based on the geometry, and just no individual piece has to flex too much. And you can take a actually really brittle PLA material and make it pretty flexible. So if you want a different kind of thing, like maybe you want it to be more like a piece of paper or cloth, then you can actually use, where did I put it? A material like this. Now, this one has got white dots all over it. This is a Christmas version. You don't need the Christmas version. It's just the only one I had. But this is tulle, Tulle, and it's going to be hard to see. It looks like it's much larger weave than it really is, because there's kind of like a subweave underneath it. I don't know if I can get it to focus. Maybe. I don't know. Oh, over in this area. Where's that at? Or over in that area, you can kind of see the smaller weave inside there. So the actual weave is probably less than a millimeter. The one that you mostly see is much larger than that because it's got larger strands in the grid. But this is tulle. Don't use this kind of tulle. So this is also tulle, but this one is definitely just the big weave. This one is too large of a weave. And what you do, the whole idea is you're trying to print something like this. So this is our print, but the tulle is embedded in it, and now it's like a piece of fabric because it's only held, all these little individual pieces are not connected to one another. They're connected to the tulle. So I made these in Thingiverse. They're just little pyramid-like shapes. And actually they're kind of concave pyramid shapes, I guess. Shape itself doesn't matter. But what I did is let me go to Cura. Oh, Cura's not, let's go to Thingiverse. Oh, not Thingiverse, Maker. Tinkercad, that's what it's called. Couldn't think of the name of it. So I can show you the part. So this is what I designed in Tinkercad. So I designed one of them and then cut and pasted, into an array. So whatever piece of software you want, these are not actually meant to be connected together. So I have like a 1/32 inch, so like a millimeter gap between the parts. And then I took them to Cura. I don't remember what I called it. Let's see. I think it's that. Maybe. Let's see if this is it. Yeah, this is it. Took it into Cura, sliced it like I normally would. I think I used a 0.2 millimeter layer height, which we're not on right now. We don't need 4 walls. We could do 2. Top and bottom layers, there's not that many layers. Right now I've got 4 solid layers, and well, 8, because 4 bottom and 4 top. I'll reduce that a little bit. That's like it's printing kind of, because I got it loaded with PETG. All right, we'll slice it. You set it up, the material properties that you want. The number of walls and all don't matter. The thing that does matter is number of bottom layers. You need to have at least 3. I think I have 3. But you probably could get away with more. Oh, we don't know, no brim though. We need the brim off. We can do a skirt. The skirt actually helps a little bit, but we don't need the brim. All right. So what you do is you print the first 2 layers. You could get by with just printing the second layer, or the first layer. But you print, there's the second layer. So you print these 2 layers, then they're on the print bed. So they're out here somewhere. Then you take your piece of tool, and you can kind of see where I had mine. It was right there. You clamp it on. You want it pretty tight. And again, all these little speckle white things on mine are because this is like a Christmas tool or whatever, and it's snow. You do not need or even kind of want that, but it worked okay with it on there. You clamp this on. You pull it pretty tight, and your part will be, actually it'll be right here. It won't be finished. It'll only be the first 2 layers. And you clamp this over the top of it. And I did clamp, 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 and I put one at the front also and one at the back to kind of pull it tight across it. So you have to pause the print. I just manually paused. I let it print the first 2 layers, and I manually paused it and put the tool on and then carried on. I was actually using, I didn't pause it here. I paused it in this one's running Clipper, so I sent it a command called pause, and it paused and moved the head out of the way. So you do have to use whatever technique you want, whether it's in your slicer, manually pause, whatever. You do need to be able to send a pause command after layer 2. So in my case, I just typed pause in the Clipper console dashboard thing. But you do need to be able to pause it so that the print head moves out of the way, and it gives you access to the print bed. Actually, mine moved over here, I think. And you put your tool on top, and then once you've got it kind of nice and tight, again, this kind does work technically, but it does this, and so they're not nearly as nice. It's even got one missing that didn't grab onto any of the little pieces. It kind of just pushes the grid around when it's this larger grid. So you need the finer one. Hit resume. It finishes the print. You take everything off. I did help it come off because all of these are actually individual pieces, and I didn't want them ripping off of the tool, or the tool's embedded between them, between layer 2 and 3, but I did use a scraper and scraped it up, and then I cut out the part, and now you've got all sorts of options of, depending on what shape you made this, it's very flexible. I mean, you can do whatever you want with it. And it's actually really, whoops, threw it on the ground. It's actually really strong because the strength is that tool. So, I mean, you can add a lot of force to it before anything's going to break, because you're basically trying to pull this fabric apart. You're basically trying to pull that apart. So that's an interesting thing that you can do, assuming you can find a piece of tool. Normally you can't find a tiny little piece. You have to have like rolls of it or whatever. But it's interesting. There are some people that go in. I wonder if I can find one. I should have looked one up earlier, but I did not. Let's see. If I can find a good example of people making interesting things out of this. If you do 3D printed fabric, you get all sorts of this kind of thing. Now, there's another kind, this one here, the one with the green and blue and white. I think that one's actually interlocking pieces. So I think that one is not using the tool. It's just using the material itself, the filament itself, and interlocking the pieces, which that's a way to do it without the tool at all. But some of these, I think this one, a lot of these others are printing on a fabric. This one printing on a fabric. So you can go the other route. I think it takes quite a bit longer to do the ones where the pieces interlock, because now you've also got to print the little interlocking hinges, and there are hundreds if not thousands of those little hinges. Another kind I guess you could do is have the pattern of the filament itself and print in a TPU, kind of like the living hinge. This one's interesting because it's a metal one. But you can do some pretty cool things by printing on fabric and then using the flexibility of the fabric. You know, a lot of these people are printing shapes that are conducive to folding in different directions. I just did squares, or that were pyramids, but they have triangles, octagons, hexagons, you know, different, I already said triangles. Triangles and hexagons seem to be the most popular patterns here. This one's kind of cool because it's got scales on it, kind of like that one. They're really easy to make, and there's plenty that you can just download also already made. But any sort of pattern that you want to create one of, and then just leave a millimeter-ish gap between them. Doesn't have to be super exact on how big the gap is. Obviously, the further apart the parts are, the more flexible it will be. But you'll kind of lose some of the effect of all of these things being joined together if they're too far apart. I settled on about a millimeter. I think this is actually 1/32 of an inch because looks like I was in inch settings down here on Tinkercad. But that's a pretty interesting way to make a kind of unique, you know, result. And if I had spaced them further apart, it would probably be a little more flexible, but it might not look quite as interesting. I actually printed this in TPU. You don't have to use TPU as your print material or filament. I just did because that was what was loaded in the printer. But any filament that doesn't destroy the tool, so I don't know what the melting temperature of the tool is, but it's not breaks down at. But that's an interesting project. Do I have any other last minute projects? Talked about that. Talked about lithophane. Well, I'll start a lithophane so that you can see it on Wednesday. Oh, I did print this recently-ish. So you can print entire board games. This one takes, I'm dropping stuff. This one takes advantage of the print in one color, then print in another. This is a board game where you put little walls in here. It's called Quoridor. Actually, there's a real game called Quoridor, but it's spelled with a Q-U. So that kind of corridor. Actually, I don't remember which way. I guess it goes this way. And the idea is that you've got a little pawn, and your opponents do. You can have multiple, and you're trying to get your guy from one side to the other, and you can either move him one space, or you can put one of your walls out. And you're just trying to block off the other person from going to the other side, and still allowing yourself to go through the other side. So you can actually print interesting little games. It takes a while to print, and I would say that if you have not gotten your print bed level, this is one piece, right? So printing something that large, it takes up the whole bed. If the bed is not level, then you will struggle to print something this large and keep it on the bed and not wanting to peel up when it takes up so much of the bed. But it is possible to do. You can even see here, didn't work so well in this area, but that's the bottom of the bed, and it survived the print overall. But there you can kind of see how it's thinner in, I don't know if you can pick up, but you can see the scarring on it on that side. A lot of times, if you'll watch that first layer, you can tune the corners with the leveling knobs here to get it worked out. If you wanted to do something with this large of a print, I would definitely do one of the print bed calibration tools where it prints a series of rectangles or squares across the entire bed, and you can kind of judge your nozzle offset from one corner to the other. There's either that one or there's one that prints a lot of concentric squares, and basically does the same thing. You're looking at how well each line of each concentric square is smushed down onto the bed. Too much smush and you run the risk of it not actually printing, not enough smush, and it won't stick too well. I did have, not this print, but I did have one of these where I was printing a really large thing on a PEI sheet. So PEI grabs to the filament really well when it's heated. And I did have something I've only ever had one time, but it was on a large print, and what happened was this is held down with just magnetic force, and printing a large object on it, it held to the plastic plastic wanted to cool and warp, and it actually peeled up the magnetic sheet. So it's easy to fix. You just clamp down the magnetic sheet onto the bed. So, you just clamp it down, and that fixed it. But if you're printing a really large surface on a magnetic sheet, then do make sure that you watch the first couple of layers and see if it's going to peel up on you or not. Or just preventively clamp it down. Now you do have to watch out these clamps, the little handles sometimes will interfere with the printer itself. I don't know if this one will or not, but let's see. Yeah, see, they'll actually, well, you can't see. They'll actually hit the uprights here. So you have to arrange your clamps in a way, or take these off, maybe take them off and just use the black part, or put them on the front and back so that there's nothing that they'll collide with. All right, I think that's enough for today. Wednesday we'll come back. I should have the lithophane printed, unless it just fails over and over again for some reason. Normally they don't fail. The only thing that causes the lithophanes to fail is when you print them, kind of like this, and the print bed's going back and forth. They'll get a little wobbly, and so they can be jagged. So definitely print them this way if you have a print bed that moves back and forth. So that should be ready to go. Maybe I will have made some progress on our canopy for our X30. It's only the canopy and the front landing gear that are left on it, I think. And then I wanted to make a stand for it. Maybe have it where we can put it on the wall or something. I don't know. But we're only like a third of the way through the course, so we've got a lot still to do. And if there's a particular thing you're interested in doing that we haven't covered, or you want to cover something in more detail, just let me know. Send an email or whatever. Put it in the Discord. Put it in the chat. And I'll try and do some of the things if I can, if I have access to whatever it is you're interested in. All right. I will be back on Wednesday, and we'll do some new stuff.